Hey guys, we're doing our 12.03 notes. So here we go. Today we're talking about Venn diagrams and tables, and they can be used to help determine whether events are overlapping or not. And if they do overlap, where that overlap exists. So we're trying to determine whether or not events are overlapping. That means that we're going to have something in the middle of our Venn diagram or not. And that's actually a vocab word. What's our vocab word for events that do not have something in the middle? If they do not have overlap, remember that is called mutually exclusive. Events are mutually exclusive if they have no overlap. Okay, so let's consider the set of all integers from 1 to 10. If you don't know what integers are, those are just whole numbers. That includes negative numbers like -1, -2, 0, 1, 2, 3. All those are integers. So we're looking at the integers from 1 to 10. Place multiples of 2 in circle A. I'm just going to make a note of that. So multiples of 2. And multiples of 3 in circle B. Place values which are neither multiples of 2 nor multiples of 3 inside the rectangle but outside of both circles. So anything that's inside of this circle is considered a multiple of 2. Anything inside of this circle is a multiple of 3. So anything outside of those circles would be neither a multiple of 2 nor a multiple of 3. So here we go. And what would be right in the middle? Those are the numbers that would be both a multiple of 2 and a multiple of 3 at the same time. So first we want to know, well, before we do that, let's fill in our Venn diagram. So integers from 1 to 10. Where would 1 go? 1 is not a multiple of 2. It's not a multiple of 3. So it's going to go on the outside. Okay, 2. Is 2 a multiple of 2? It is, but is it a multiple of 3? No. So it's not going to be in the middle. It will only be in our multiple of 2 circle. Okay, 3 is a multiple of 3, but not a multiple of 2. 4 is a multiple of 2, but not a multiple of 3. 5 is neither. Okay, 6. 6 is a multiple of 2. 6 is also a multiple of 3, so it's going to go in the middle. 7 is neither. 8 is a multiple of 2. 9 is a multiple of 3. And then 10 is a multiple of 2. Okay, A, we want to know how many members of the set are multiples of 2. Now, sometimes Venn diagrams can be a little tricky. Sometimes people go too fast and they say, okay, that would be 1, 2, 3, 4 numbers are multiples of 2. But that is incorrect. Anything that is inside of this multiple of 2 circle is a multiple of 2. So we have to also include what is both. 6 is a multiple of 2, so we have to count it. So we're going to have 1, 2, 3, 4, 5 numbers that are members of multiples of 2. How many members of the set are multiples of 3? That's going to be 1, 2, 3. Anything inside of that multiple of 3 circle. Okay, how many members of the set are multiples of both 2 and 3? Only one, only the number 6. So we want to know, are the events multiple of 2 and multiple of 3 mutually exclusive? What does mutually exclusive mean? We're asking, do these have overlap? So mutually exclusive means no overlap. Do these events have no overlap? The answer is no, because they do have overlap. 6 is a multiple of 2 and 3. That would be your explanation. So this question can be very tricky for people to say. Are these events mutually exclusive? You're asking, do these have no overlap? The answer is no, because they do have overlap. Or their answer is yes, because they do not have overlap. So it can be a little bit tricky to answer that question. So make sure you really understand that definition and that you are answering this correctly. Okay, E. I want to find the probability that I pick a number that is a multiple of 2. So first we need to figure out how many numbers are a multiple of 2. Again, you have to count all the numbers inside of that circle, including the 6, because it is still inside of that multiple of 2 circle. So that's 1, 2, 3, 4, 5 numbers that are a multiple of 2. Out of how many numbers total? We have 10 numbers total, and that reduces to 1/2. How many numbers are a multiple of 3? So that's everything inside the multiple of 3 circle. That's 1, 2, 3 numbers out of 10 total. Finally, what's the probability of a multiple of 2 and 3? So remember, this is both. How many numbers are both 2 and 3? That is only 1 number out of 10. Okay, and finally, a multiple of 2 or 3. So our OR formula that we learned last week told us to take the multiple of 2 plus the probability of 3, and then subtract the probability that both of them could happen in a given number. With a Venn diagram, you don't have to follow that formula because we can already see the overlap. That formula that we use is in case we can't physically see what the overlap is. So all the numbers that are 2 or 3, that's just really any number that is inside of this Venn diagram. So that would be 1, 2, 3, 4, 5 numbers. Sorry, 1, 2, 3, 4, 5, 6, 7 numbers out of 10 to get that answer. Now you could follow the formula, but you're going to have to think about it a little bit differently than probably what you would normally expect. So if we're following our formula, that's the probability of 2 plus the probability of getting a 3, and we're subtracting the probability of a 2 and a 3 at the same time. So what's our probability of rolling a 2? We just found that a minute ago. That was 5 numbers out of 10. That's including the 6, because that's everything inside that circle. Plus the probability of getting a multiple of 3. That's 3 numbers out of 10, including that 6. But now we've just counted that 6 twice, so we need to subtract the probability of getting a 2 and a 3 at the same time. There was 1 number that was counted twice, so we need to subtract that 1 number. And that gives us our 7 out of 10. So you can do it by following the formula that we talked about last week, or you can do it by just simply looking at how many numbers are included inside of those circles of our Venn diagram. And either way, you're going to get the same answer. Okay, next is a contingency table. So we have a survey of students that were asked to pick their preference of 3 different sports. The computer malfunctioned and lost some of the results. Using the given values, fill in the rest of the table. So how one of these tables works is anything in these rows are going to total up to 17. That's what that subtotal means. So these two numbers together should add up to equal 17. Whatever these 2 columns will add up to equal, that will go in this subtotal. So that works for all of the columns. It also works for all the rows. So every single male number in that row should add up to 50, and in the female row, these 3 numbers should add up to 50 also. So let's look at that. So again, these need to add up to 17. So 17 plus what gives me 17? Well, that means 0 numbers. 0 females would like baseball in order for that column to work. What else can we add up? We know this row needs to add up to 50. So 29 is the numbers that we have. What do we need to get 50? So we need 21 females who like basketball in order for that row to equal 50. And then for this row, 17 plus 13, that's 30, so we need 20 more. This column adds up to 49. And this column adds up to 34. Now, this box here where our two subtotals meet, that's going to be our grand total. That tells me how many people total were in this survey. Also, each of these columns and rows should add up to be the same number. So 50 plus 50 we know is 100. And let's just check 17 plus 49 plus 34. Let's check that really quick. 17 plus 49 plus 34, and we get our 100. So either way, we should make sure that we get our grand total of 100. That means we had 100 people in this survey. So now I'm trying to find the probability that somebody in this survey liked football. That means I need to look at the football category. I don't care if they're male or female. I just want to know how many people like football. So I look at that subtotal. That means 49 people liked football. 49 out of 100 is the probability, because 100 was our grand total in the survey. Okay, females or basketball. Remember, when you see or, you're going to have to add and then subtract the overlap. So first, let's find the total number of females. How many people were female in this survey? 50. So I have 50 out of 100 plus, now the probability of someone liking baseball, that's 17 out of 100. Don't forget to subtract your overlap. How many females liked baseball? Female and baseball, so where those two columns and rows cross, that means that's how many people, that's the both. That's how many females picked baseball. That's our overlap. So we're subtracting 0 from that because there are no females who like baseball. We add that up and we get 67 out of 100. Okay, how many males, or sorry, the probability of males or basketball. Remember, when you have or, you need to add and then subtract your overlap. How many males did we have? We had 50 out of 100. That's the probability. Plus basketball, we had 34 out of 100. And now let's subtract our overlap. We have males who like basketball. That would be 13 males who like basketball, so we have to subtract that 13 out of 100. And that brings our total to 71 out of 100 for the probability of male or basketball. Always think about that subtraction. I would say that's probably one of the most common mistakes. Anytime you have or, you have to add and then subtract. Make sure you are subtracting even if you are just subtracting 0. Okay, are the events of female and baseball mutually exclusive? So female and baseball, are they mutually exclusive? So really what we're asking is, remember, mutually exclusive means no overlap. So what we're asking is there no overlap for female and baseball? Is there no overlap? Since where they cross is 0, the answer is yes. There were no females who liked baseball. Okay, are the events male and football mutually exclusive? Remember that mutually exclusive means that there is no overlap. So what we're asking is there no overlap for male and football? So let's look. Male and football, is there no overlap? The answer is no, because there is overlap. I would say there are 20 males who like football. So when you're answering a mutually exclusive question, it can be a little bit tricky because your answer kind of has a yes, no component to it. You're either saying yes because there were no overlap, or there was no overlap, or you're saying no because there are people in that overlap. So your answer should always be no because yes, or yes because no. Okay, last problem on the back. Okay, Debbie counts the videos and DVDs she has and places them into categories. So it's the same as the last one. Some of these numbers are missing. So let's try to figure that out. Well, I know our grand total is 100. That's going to be our total in all of our probability problems. That's our grand total. There are 100 total, and there are 24 people who wanted DVDs. That means that there are 76 people who had videos, or 76 videos that Debbie had. Okay, and let's subtract some of these other ones. For this column, we want our total to be 76. We have 43 and 21 videos already, so that means there are 12 comedy videos. And 12 plus 5 does add up to 17, so I know that's correct. For this column, we have 24 total. 24 minus 5 minus 16 gives me 3 DVDs for sports. 21 plus 3 is 24. And then 43 plus 16 for this row, that gives me 59. And let's make sure that adds up to our 100. 59 plus 17 plus 24. Yep, we get a 100. So you should always be able to check yourself with these numbers. That way you don't accidentally mess up the rest of the problems just because you filled in the table wrong. Make sure all the columns add up correctly, all the rows add up correctly, and that your grand total is adding up to what it's supposed to be. Okay, we want to find the probability of getting a DVD. So in our DVDs, there are 24 DVDs total out of 100. And then we want to reduce that fraction, 24 out of 100, 6 out of 25. That is the probability. Okay, video or comedy. When you see or, like we learned last week, you're going to add and then subtract. So for our video probability, there are 76 videos total out of 100. Plus for our comedy, there are 17 movies total out of 100. And then we're going to subtract, don't forget to subtract that overlap. How many videos were comedies? So videos and comedies, they overlap at 12. There were 12 movies that were both. So let's subtract that, and we should get 81 out of 100. For our probability. Okay, DVD or sport. Remember with or, we're going to add each probability and then subtract. DVDs, we had 24 out of 100. Plus sport, we had again 24 out of 100. Now let's subtract the overlap. DVDs that were sports, there were 3 of them. We have to subtract that 3 and we get 45 out of 100, which reduces to 9 out of 20. Okay, film or video. Remember with or, we're going to add and then subtract. Film, we had 59 out of 100. Plus video, we had 76 out of 100. And then we subtract the overlap. The film that was videos is 43 out of 100. So we have 59 plus 76 minus 43 gives us 92 out of 100. And that gives us 23 out of 25 for our probability. Okay, for this problem, let's say that you forgot to subtract your overlap. Okay? Let's say you just added, because sometimes we subtract 0, so a lot of people like to drop that 0, and let's say you forgot to think about the overlap. So you only added 59 plus 76, and you got 135. So you got 135 out of 100 for that probability because you forgot to subtract the overlap. Looking at that answer, how would you know that you got that wrong? The reason why you should know you got that wrong is because no probability can be over 1. That is impossible. This number on the top can't be bigger than 100, the denominator, because no probability can be over 1. So that's a way to check yourself. Make sure that your answers are always fractions that are less than 1 or decimals that are less than 1. If you have any questions, message me on Remind or stop by my live chat on Tuesday, and you can ask as many questions as you want. Have a good day.